When we look at the world's most powerful storms, those swirling tempests that can reshape coastlines, flood entire cities, and leave lasting marks on history, we often hear terms like hurricane, typhoon, and cyclone. These aren't just different words for the same phenomenon. They are signs of how nature's forces transcend borders, yet are named and understood within the context of culture, geography, and science. But what exactly are these storms, how do they form, and what makes them so destructive? Let's embark on a journey through the science of natural disasters, focusing on the awe-inspiring power of tropical storms, and uncover how climate change is altering their frequency and intensity. To begin, all three terms, hurricane, typhoon, and cyclone, refer to the same type of storm. A tropical cyclone, which is a rapidly rotating storm system characterized by a low-pressure center, strong winds, and heavy rainfall. The difference in names arises purely from geography. In the North Atlantic Ocean and the Northeast Pacific, these storms are called hurricanes. In the Northwest Pacific, the same systems are known as typhoons. And in the South Pacific and Indian Ocean, they go by the name cyclones. Despite the different labels, the science behind them remains unified. Tropical cyclones form over warm ocean waters, typically when the sea surface temperature is at least 26.5 degrees Celsius, or about 80 degrees Fahrenheit. This warmth is crucial, as it fuels the storm's engine. As the sun heats the ocean, water evaporates, and the moist air rises into the atmosphere. As it rises, the air cools, causing water vapor to condense into clouds and release latent heat. This process warms the surrounding air, causing it to rise faster and draw in more air from below, which in turn brings in more moisture. A feedback loop is created, with each stage intensifying the process. As more and more warm air is sucked upward, the system begins to rotate due to the Coriolis effect, which is caused by the Earth's spin. This rotation is what gives tropical cyclones their iconic spiral shape. At the heart of these storms lies the eye, a calm, clear center surrounded by the eye wall, where the most violent winds and heaviest rains occur. The eye itself can be eerily peaceful, with light winds and even glimpses of blue sky. But just outside its boundary, conditions can be catastrophic. Winds can exceed 150 miles per hour in the most powerful storms, capable of ripping the roofs off houses, uprooting trees, and turning debris into dangerous projectiles. But it's not just wind that makes these storms so dangerous. Torrential rainfall can lead to catastrophic flooding, inundating streets and homes, overwhelming drainage systems, and causing landslides in mountainous regions. Perhaps most deadly is the storm surge, a rise in sea level pushed ashore by the force of the winds. The surge can flood coastal communities, erode beaches, and destroy infrastructure. Many of the world's deadliest hurricanes, typhoons, and cyclones owe their high death tolls not to the winds themselves, but to the flooding caused by storm surge. The regions affected by these storms vary according to their names. Hurricanes threaten the eastern United States, the Caribbean, Mexico, and parts of Central America. Typhoons regularly batter East and Southeast Asia, including the Philippines, China, Japan, and Taiwan. Cyclones strike India, Bangladesh, Australia, and islands throughout the South Pacific. Each region has its own storm season, shaped by ocean temperatures and atmospheric patterns. Understanding the science of tropical cyclones is not only vital for meteorologists, but also for the millions of people who live in at-risk regions. Forecasting these storms requires a combination of satellite data, weather models, and on-the-ground observations. Modern forecasting has made tremendous strides, giving people more time to prepare and evacuate. However, despite advances in technology, the sheer power of these storms means that devastation can still be severe. Now, as the climate changes, the nature of these storms is shifting. Scientific evidence indicates that warmer ocean temperatures, driven by global warming, are providing more energy for tropical cyclones. While the total number of storms each year hasn't risen dramatically, the proportion of the most intense storms, those in the highest categories, appears to be increasing. In other words, while we may not see more storms overall, the ones that do form are more likely to be powerful, long-lasting, and destructive. Climate change also influences rainfall patterns, making storms wetter and increasing the risk of flooding. As the atmosphere warms, it can hold more moisture, leading to heavier downpours. Rising sea levels, caused by melting glaciers and polar ice caps, amplify the dangers of storm surge, pushing water farther inland and affecting more people. Let's consider some recent examples. Hurricanes like Katrina, Harvey, and Maria have inflicted record-breaking damage on the United States and the Caribbean. Typhoon Haiyan, which struck the Philippines in 2013, was one of the strongest storms ever recorded, leaving thousands dead and millions homeless. Cyclone Idai devastated parts of Mozambique, Zimbabwe, and Malawi in 2019, causing widespread flooding and loss of life. The impact of these storms goes beyond immediate destruction. They can disrupt economies, destroy crops, contaminate water supplies, and displace entire communities. Recovery can take years, especially in poorer regions where resources are limited. The trauma of loss, both of loved ones and livelihoods, can linger long after the skies have cleared. Yet amid the devastation, there are stories of resilience and adaptation. Communities are building stronger homes, elevating infrastructure, and improving evacuation plans. Advances in meteorology and communication technology are helping to save lives, as warnings spread faster and more people heed the call to prepare. In addition to hurricanes, typhoons, and cyclones, another type of violent storm often captures our attention: the tornado. While tornadoes are different from tropical cyclones, forming over land from severe thunderstorms rather than over warm ocean waters, they are also a product of the complex interactions between weather patterns and geography. Tornadoes are characterized by their rapidly rotating columns of air, capable of tearing through towns in minutes and leaving behind narrow trails of devastation. Tornadoes are most common in regions like the central United States, in an area known as Tornado Alley, where the collision of warm, moist air from the Gulf of Mexico and cool, dry air from Canada creates ideal conditions for these violent storms. Unlike hurricanes, which can be tracked for days as they move across the ocean, tornadoes can form and dissipate within minutes, making them especially challenging to predict and prepare for. Both tornadoes and tropical cyclones serve as reminders of the powerful forces that shape our planet's weather. They highlight the need for ongoing research into the science of storms, improved forecasting, and better preparedness. As our climate continues to change, understanding these natural disasters becomes ever more critical, not only for those living in vulnerable regions, but for all of us, as our interconnected world faces new challenges. In summary, whether we call them hurricanes, typhoons, or cyclones, these massive storms are a testament to the dynamic nature of our planet. They are shaped by the interplay of ocean and atmosphere, influenced by global weather patterns, and increasingly by human actions. By learning about their formation, understanding their impact, and adapting to their increasing intensity, we can better protect our communities and build a more resilient future. The science of weather is a story of awe, danger, and hope, a story that continues to unfold with every storm season.